G'day guys, I've got a video for you today on adding and subtracting algebraic fractions. What we're going to do today is we're going to combine these two algebraic fractions here and here, and after we've done those we're going to use the tools or the knowledge that we gain from doing these particular questions to then solve this equality down here. Now let's get started. So with this first problem here, when we add and subtract algebraic fractions, like we would with regular fractions, we need to ensure that the denominators are the same. So in this case, where we have two denominators which don't have any factors of each other, like this x plus 2 is not a factor of x plus 3, we can simply multiply them together. So let's just make a big line. So this is going to be equal to, now let's make a big line. We've got x, if we multiply these together, we're going to have x plus 3 times x plus 2. Now, if we're going to combine them like this fraction here, to get the x plus 3, the original denominator, to this new denominator, we had to multiply it by x plus 2. So we're going to multiply the numerator, 3, by x plus 2. So we have 3 times x plus 2. And similarly, we have this minus 2 here. We're going to multiply, to get x plus 2 to x plus 3, x plus 2, we have to multiply it by x plus 3. So we're going to multiply the negative 2 by x plus 3. Cool. So we've combined them together, so now they're just one big fraction now. Now all we have to do is just multiply out our brackets in the numerator and then combine our like terms. So let's do that. So what we're going to have is we're going to have 3x plus 6 minus 2x. Minus 2 times 3 is minus 6. All divided by x plus 3, x plus 2. Now, in the numerator we've got 3x take 2x is x, or 1x. 6 take 6 is 0. So in the numerator we're just left with an x. And then in the denominator we can leave it like this. We've just got x plus 3, x plus 2. Cool. And that is the solution for our first one. You could multiply out the bottom brackets, but I feel like it looks a lot neater when you've got it in fully factored form anyway. Okay, so let's go about doing this second one. Change color. Now, the first thing we have to do here is, if we're going to try and get these two denominators equal to each other, we're going to, like we did over here, we're going to be multiplying them together, but we're only going to multiply the factors that they don't have in common. So what we have to do to start with is we have to fully factorize both denominators, because otherwise we're going to have to multiply x squared minus 4 by x squared minus x minus 6, and we're going to have this really messy denominator and quite messy numerators. We'd get the same answer after a while, but it would take a lot longer. So let's go about factorizing these two denominators. So we're still going to have a 1 up the top for the first one, over. Now hopefully you guys recognize that this here, to factorize it, is a difference of perfect squares. So what that means is we can just take this is going to be x plus 2, x minus 2. And that's what this will factorize to. Now we have this x squared minus x minus 6. We're looking for two numbers that multiply together to give negative 6 and add together to give negative 1. So we have 1 over. Now that's going to be negative 3 and positive 2. So we have x plus 3, x plus 2, x take 3. Now, you can see here that these guys share a factor of x plus 2. So when we try and put the two denominators together, we're not going to have to multiply them by x plus 2. They can stay. But we're going to have to multiply this denominator by x minus 2, and we're going to have to multiply this denominator by x minus 3. So let's go about doing that. So this, now, we're going to have one big fraction, and all the denominator is going to look like this: x plus 2, x minus 2, and then x minus 3. Now, once we've got all of those are all of our factors. So what did we have to multiply this denominator by to get to this larger denominator? We had to multiply it by x minus 3. So let's multiply the numerator 1 by x minus 3. So we just have x take 3. Minus, what did we have to multiply this denominator by to get to here? X plus 2. Sorry, x minus 2. Can't read my own handwriting. Now, like we did in this question, we're going to combine our like terms in the numerator. X take x is nothing. Negative 3 take negative 2. Negative 3 plus 2 is negative 1. And that's going to be over x plus 2, x take 2, x take 3. Cool. So here, what we had to do first is we had to factorize our denominators so we could figure out what factors they had in common, and then after we did that, we would know what we have to multiply each of them by to get our common denominator. Okay, so on to the next one. Let's just separate these two types of questions. Now, what we're going to do here is we're going to solve this, to solve this, what we're going to do is we're going to combine all our denominators together, and we're going to use that to combine all of our numerators together to form one big fraction. And because it equals 0, you'll see that we can use a couple of tricks that will make the algebraic process at the end quite a lot easier. So let's have a go. So you can see that this is in fully factored form in the denominators, and what that means is we're not going to have to do any more factorization, and to get the same denominator across all of these fractions, we can just multiply all of the denominators together. So what we're going to have to start with is a take 2, a take 4, a take 5. So we've just multiplied all of our denominators together. Now, where it's a little bit more tricky than that is in the numerator. So what we're going to do is a take 2 to get to this had to be multiplied by a take 4 and a take 5. So we're going to multiply the numerator by that. So we have 3, a take 4, a take 5, plus 5. A take 4 had to be multiplied by this one and this one. So we have a take 2, a take 5, minus 4. Now a take 5 had to be multiplied by these two denominators. A take 2, a take 4. Cool. So once we've done that, and this is equal to 0. Now here's one of the first tricks we can use. If we multiply both sides by the denominator, we can effectively, on the left, cancel out the denominator, but what will happen is if we multiply 0 by the denominator, it's still going to be equal to 0. So we can effectively just get rid of the denominator. So what we're going to have now is we're not going to have any fractions, it's a pure algebra exercise. So to start with, I'm going to multiply out my binomial, or my brackets here. So I'm going to have 3 inside of, so it's probably good if you guys practice multiplying out these quadratics here in their fully factored form, because it'll make your life a lot easier when it comes to doing questions like this. For example, we've got 3, and this is going to be multiplied by a squared minus 9a plus 20. And this is going to be added to 5, multiplied by a squared minus 7a plus 10. minus 4 times by a squared minus 6a plus 8 equals 0. Cool. Now, again, before we combine any of our like terms, we have to multiply into the next bracket. So we have 3a squared minus 27a plus 60 plus 5a squared minus 35a plus 50 minus 4a squared times minus times a minus is a plus 24a minus 8 fours are 32 equals 0. Now we're going to combine our like terms. So I'm going to move this up here. So we've got 3a squared plus 5a squared is 8a squared. Take 4a squared is 4a squared. Then we have 27a minus 35a plus 24a. So we could combine the first and last ones first to get negative 3. Negative 35 minus 3 is negative 38. And we have 60 plus 50 is 110, minus 32 is 78. Cool. Now, so we're left with this non-monic quadratic equation here. So we're just going to have to go about factorising this so we can use the null factor law to solve it. So to start with, we can see that all of these numbers have a common factor of 2. So let's do that first. So we have 2 outside of 2a squared minus 19a plus 39 equals 0. Oh, don't know why that bracket's there. Cool. So then what we're going to do is we're going to times 2 by 39 to get, again, 78. So we can use this. Sorry, that 78 looks really bad. So we can get 78. So we can then use that to split that b term in the middle. So two numbers that multiply together to give positive 78 and add together to give negative 19 is going to be 6 and 13. So we can also divide the 2 across. So 0 divided by 2 is still 0. So we're going to have 2a squared minus 6a minus 13a plus 39 equals 0. We're going to then factorise the front 2 and then factorise the back 2. So 2a squared and 6a, well, we have 2a outside of a minus 3. Then we're going to have negative 13 outside of a minus 3 equals 0. We then are going to factorise this by a minus 3. You can see there's a common factor there. That's times by 2a and minus 13. Now I'm assuming you guys are fairly well versed in non-monic quadratic factorisation. If you're not, I'll put a link to one of my, or a couple of my videos that I've done on that specific subject that you can brush up on that sort of technique. So using the null factor law from here, which we can say that a is going to be either equal to 3 or a is going to be equal to 13 over 2. So this one at the bottom here is quite in-depth. You've got first of all, because you've got 3 fractions, none of them have any common factors. So then you have to multiply out 3 different quadratics. You then have to combine your like terms for 3 different quadratics. Inevitably, you get a non-monic quadratic equation, which you then have to factorize to be able to use the null factor law to solve for a. Now, the only thing really in this question that stopped our algebra being too huge was the fact that it equaled 0, which was nice. That makes us happy because you can then multiply the denominators across and divide by any common coefficients, and it still will equal 0. There's no algebra required. So I hope this video helped, guys. If it did, give it a thumbs up. If you'd like, subscribe to my channel. I put out new videos all the time, and I'm happy to answer questions if I can, or if you're struggling with anything. But until next time, guys, I guess enjoy your maths.